Welcome back to Incremental, the continuous improvement podcast. This is our practice edition where we talk about the improvements we've made this week and tie them back to lean principles. I am Uriel Eisen.
And I am Devin Bedoni.
And Devin, you have a quote?
I do. Progress will never pay a visit to those who stubbornly insist that their way is right and no other means are possible. Yet, if we keep an open mind and believe that there are several possible means to each end, improvement ideas will emerge through the process of selecting the best method. Thus, the single most important prerequisite for improvement is an open mind. Shigeo Shingo, Key Strategies for Plant Improvement.
Blam.
Mic drop.
Open up your mind.
We've been talking about this a lot, but it seems to be... Shigeo said it, so it must be true.
Yeah.
It's important.
It is.
Don't assume.
Yeah, and reading his books, basically it is a bunch of stories of him going into plants and they explain why things are kind of messed up and they want improvements. And he's like, it's not inherent. Like there's a view that they have that what they're doing. Like I remember one where they were preheating some food product at a bakery and they were bottlenecked by their oven.
Right.
And it was like a very long process to warm it up. It was inconsistently warmed and that caused issues down the line, but they were packing as much into the oven as possible to get their and he was like, what? Yeah. And the answer turned out to be, which is an open mind, thinking about this, which I think, tying back to last episode, only comes from really thinking hard about what is the actual problem. And the actual problem was total throughput, not how much was in an oven. Yeah. And so he recommended putting less in the oven so you'd have more heat, you'd have more airflow between them. Mm-hmm. I forget if they added a fan to move more air. I don't remember, but just by spacing out the material in the oven so there was air between everything reduced the cycle time substantially. Yeah. So that they could more quickly pass stuff to the next process. So they actually reduced their batch size, which decreased batch delays. Yeah. Simultaneously, the increased airflow also total in 24 hours, they could do a lot more. It almost doubled, I think, their throughput. So
interesting. This is totally an aside and a distraction, but when I was in like 5th grade, you know how like in classrooms, like there's these weird fads that happen and they just make whatever. Yeah. Some kid does a thing and then everybody's like, I want to do that too. Yeah. Somehow this fad started where everybody was bringing like their own microwave lunches.
Oh, funny.
But there was one microwave and so looking back on it, the solution is clear. Everybody would pack their stuff into this microwave all together. And because there was so much food in there and there's only so much energy in a microwave, right? It just would take it'd be like going for like 15 minutes and no one's food was hot. And like we would just do this day after day after day. And like
if only Shigeo had paid a visit or if you guys have had an open mind.
Dude, the answer was quite clear that each person could have in turn put their food in for like a minute and a half and it would have been hot. Right. But that would require some organization and someone being willing to go last. And as 5th graders, we were not capable.
Yeah. That makes sense.
It's just
great
funny. Quote. Single piece flow. It's the way. Yeah. Even with lunch.
Even sort of.
Maybe.
Unless you're trying to have a social meal. We were talking about, a few improvements to the podcast. We added an external screen where we're recording so that both of us can see the recording time. Mm-hmm. Someone had asked about improvements, to the podcast. So we're trying to share them. So we did that. We also updated we standardized the intro for the practice edition. So if anyone can think of an update to that standard, please write in. And we also recently, we used to record and then go our separate ways. I would do the show notes and then you would upload it and we'd do that sort of the morning of. So if people have noticed that we're a little more consistent with posting it in the morning, the reason is we now have combined the posting process with recording. So now the second we finish recording each episode, we do the full upload. We write the notes while it's still fresh in our heads, which has made that process a lot easier.
Mm-hmm.
Post it and schedule it. And yeah, that reduces WIP. So all of the time that was invested, well, I guess it still publishes. So it still sort of adds value to the end consumer, hopefully, at the same time. So maybe the WIP is the same.
Well, no, from
think
us doing work standpoint, the work is done.
The work is done. Yeah, that's true. From stuff being on our to-do list.
Yeah.
So now it's not on our to-do list, and I think the quality increases because there's less of a delay between recording it and writing the show notes, which I think has been helpful.
It's also just overall faster, I think. Everything's open.
True.
Right here.
Yeah.
It's less.
Yeah, there's not the waste of... I've been thinking about that actually a lot in our shop. I think it's a hidden waste. It's not hidden. It's like totally identified by Toyota and everyone else, but I think to the person in the shop, it's hidden. Every time you set something down to then pick it up later, that is all waste. Mm-hmm. And that is why one of the big reasons single piece flow is huge is because things don't get put into storage and taken out of storage again. Mm-hmm. And similarly, to your point, we would record, put everything away, close the browser, Windows, whatever. Yeah. Then all that time of going and finding the correct one, clicking into the correct episode, that is all wasted time. Anyway. Yeah. We also decided a new standard for the episode, which is we're going to try to just trade off improvements.
Yeah.
Yeah.
Anyway. Pressure on me to keep up.
Oh, no, whatever.
Otherwise, we'll be out of sequence, and then the whole show will fall apart.
It'll just end.
Oh, Devin's out.
No.
You want to lead us off?
Oh, sure. Let's see. Quick review of the 8 lean wastes: overproduction, overprocessing, excess inventory, defects, transportation, wasted motion, waiting, wasted human potential. We've started doing these also in our in our shop because I just feel like we've talked about this, but adding lenses to looking at your current state is really helpful to fight the issue of becoming habituated to the way you're doing things is what I found. Yeah. So like there's a really fun one that I saw from, it's a little depressing, but also awesome. From Seating Matters. Yeah. Where as someone working in a station, you can just say to yourself, like even out loud, no value, no value, no value, no value, value. Yeah. No value, no value. Just to...
Pointing at different things that you're doing?
No, as you're doing the process you're meant to be doing, the only time you're adding value is when a material is changing shape, right? Or changing state. Or so like assembling, disassembling, like in paint, the only value add is when paint is landing on the part. Yeah. Everything else is waste. And it can be demoralizing because it's about 85% of what you're doing is waste. But it really brings into focus series of movements that or processes that we've spent time refining, but actually we need to spend time eliminating, right? Like, we made it faster to pick up this screw instead of eliminating a screw from the assembly or something like that. Anyway.
I was, another aside, but I was working in paperless parts this last week, doing this first like large quote that I'd done. Yeah. And I was trying to figure out how to do like basically like an add-on, like tooling cost plus this. And it was like 16 different part numbers. So I was going through and like editing all of these different part numbers over and over and over and over again. Okay. And it was kind of like that concept you've talked about of being like, to highlight something even further, to like pick it up, put it down, pick it up, put it down. Like if you have to do a thing, repeat it. And it made it very clear like where the pain points were. Interesting. And it was actually really helpful. And I made some notes. And then in the next meeting, I was like, okay, so I think what I really need is some templates for this and this, because I'm finding myself like deleting every single time, deleting every single time. Interesting. Or forgetting and leaving stuff in there that shouldn't be in there. And it was kind of cool to like actually see that in practice of being like, okay, so if I force myself to repeat this process 6 times, it really becomes clear where the issue is. And I think when you do a repetitive process, but it feels new every time because it's a new part. It's harder to see that than when it's the actually like literally just the same thing over and over
wow.
again.
Yeah. Yeah. I think that's basically, I mean, batch work, I think, hides inefficiencies instead of, you're amortizing it. That is cool. Yeah. So an actual improvement we made, pneumatic assembly jigs.
Yeah. You sent me a video.
Yeah.
I was curious that, I mean, it's just kind of like, it dropped a video, didn't say anything. I was like, this is cool.
Yeah. So basically, we've been taking things step by step with our target being reducing assembly time on the assembly in the assembly area, and sort of just taking little steps at that. So the first thing we did, well, back, I guess, two plus years ago, I realized we needed an assembly jig, and I 3D printed this little cradle where you'd lay a body in, and then you'd pick up a pair of pliers. You'd pick up a spring with a pair of pliers, sort of hold it in the right position, press the cam down while catching the back of the spring. Yeah. Hold that all in position, then sort of pick the whole thing up and push a pin through it sideways. Yeah. It was very... there was a learning curve because if you messed it up, it would scrap apart because the spring would sort of slip out and scratch the part. We used that for probably a year, and you get a lot better at it, right? But it's still bad. So then I built a mechanical version and the big challenge, it took me quite a while to solve, was how to bring the parts together fully constrained, that would align, that would allow you to put the spring in. Getting the spring in as a really confined space was tricky, but a fully mechanized process that had no feel. Yeah. And so figured that out, and it was all manually actuated, but that was a huge step forward.
And that's what you've been using up until recently?
Yeah. So that's what we were using. And actually on the 1-inch cams, because we've sold fewer of them, which I think has to do with the fact that we don't offer them in all the colors. But we're starting to sell a lot more of them. Until recently has been that old cradle.
Oh, interesting.
With the pliers. And Sam was not a big fan of that. Anyway, so we got a big order recently for 1-inch, and I was like, okay, this is a good time to update. So I built one again for the 1-inch that was all mechanical. This time I realized on the last one, the body was fixed, and then the cam was in a moving carrier, and then the spring injector was also in a moving piece. And I realized I wanted to feed the springs from a vibratory bowl feeder. Yeah. And so having a moving spring injector was a problem. And so with the 1-inch, one of the design goals was a fixed spring injector so that down the road it can be fed from a vibratory bowl feeder. So did that, made that. Turns out you don't have enough hands to actuate everything that needed to be actuated on that one. And so we sort of like retrofitted a bit. We assembled a few, and then I just decided to make it pneumatic because it's something we've been meaning to do. So yeah, just designed one, 3D printed it, bought some pneumatic actuators, some cheap pneumatic actuators. Went for a pretty small piston size so I stuck my fingers in it and actuated it, and it's fine. Like that was the goal, right? Yeah. I just turned the regulator all the way down and then sort of brought it up to pressure and made sure it functioned, made sure it wouldn't hurt you.
I like that was your test, though, straight to the finger.
I was like, if I'm not willing to stick my fingers in it,
Well, no, but you could have tested it on a hot dog or something first.
No, but I tested it with like zero pressure first, right? And slowly brought it up.
Gotcha.
And it was really gentle, and then it got less and less gentle. And anyway, yeah, that's true. But yeah, so that reduces...
So are you using it like on the daily?
Yeah, it's awesome.
Cool.
Yeah. I didn't solve all the problems. Like at some point in CAD, when you're like, how am I going to attach that thing to that thing? Yeah. And I was just like, I don't know. I'll figure it out. I just printed it, and we're just like crazy glued the parts together, which is working. Yeah. And then it popped apart, and so we glued it back together, and now I'm going to figure out I couldn't find a spec on the threaded holes because I bought some cheap pneumatic actuators. Oh. So I didn't know what the threaded hole was.
Gotcha.
So I have to, on my list is to figure that out and CAD in some screw holes.
Yeah, gotcha.
But yeah, it works great. And the second we had it done, it just occurred to me. So firstly, the reason we added it is noticing, like, there's a lot of wasted motion of putting the parts in. Then you have to move your hands over to the back of the carriers to push them together. Then you have to lock it. Then you have to go reach for a pin, carefully insert the pin into the hole, tap that down. Then you release the hole, the assembly jig, and then you move the partially assembled buckle into a press and press the pin in. The second I saw that, I then picked up the whole assembly jig and stuck it into the press. So now you can assemble it in the press.
Oh, cool.
Without your hands being in the press, because the carriers travel a good distance.
Oh, I was wondering why
all the way
were
out
so far. Yeah.
You insert the part, then it carries them in. And so I think we're going to I have a pneumatic press, but it's kind of massive and can do like 6,000 pounds, which is definitely like ruin your fingers.
Yeah.
And so I'm kind of on the fence about whether as a next step to just order another cheap arbor press and just have a dedicated one for each size, or if I should put it into the pneumatic press. If I do put it into the pneumatic press, do I buy a pneumatic press for each product, or do I do a quick change on the existing product?
Do you know how much pressure it takes to press the pin?
I would guess it's like 500 pounds. It's not a lot.
Because
it would still wreck your fingers.
Sure. You could just buy another cylinder that's a little bit bigger and integrate it into the tool.
That's true. Build my own press, basically.
Yeah, but it might not even have to be that.
That's a good point.
Complicated. Like maybe not 3D printed. Like you might need some metal, but very simple. Yeah,
I was definitely sort of dusting off some of the specifics of SMED in this and thinking about using a press. I'm realizing I should come up with a standard, even if it's one for each one, a standard press height.
Yeah.
Like how tall, where does the piston go down to? Yeah. And if that is always standard across every press, then that will be big. And so I'm just deciding on our maximum buckle size that we could conceivably do down the road. I mean, not conceivably, but within reason, that we have plans to do. And then I'll build all the press tooling so that the top face of the pin ends up at the same distance from the platen, basically.
Yeah.
When it's pressed.
Yeah.
So that was, standardized.
Or, honestly, on a pneumatic cylinder, you don't really care where it ends because the bottoming out isn't really a big deal. It's more about where it retracts to and having minimal over travel.
I don't want it to be able to go down further than the set point. Where that pin gets pressed to.
It doesn't hit a hard stop?
I'd rather the hard stop be in the press, I think.
Okay.
I think. Maybe I'm thinking about it wrong. I'll have to think about that.
Yeah,
so that was that. And then, so this is just like taking little swings at specific issues. So I think we can tackle that problem. My brother Elisha a while ago was visiting, and he designed a set of fingers that holds a pin so that you don't have to tap the pin into the body and then insert it into the press. It holds it below the arbor press fingers. The arbor press comes down and presses it into the body, and then those fingers sort of just swing out of the way.
Yeah.
So I kind of want to get that integrated next, and then you can just drop a pin down the side, and there's just a chute that carries it right into those fingers.
Yeah.
Is the goal.
I just had another thought.
Yeah.
If you do start turning your pins, you could turn
them to order and drop it right into the press. Someday.
No, you could turn one end to a smaller diameter. And then you could under ream the far end of the buckle.
Yeah.
So that you had a section of pin that would just drop right into the hole.
Like a lead-in kind of.
A lead-in alignment.
That's a cool idea.
And then it would press through, and then it would press into the far side.
Right.
You'd have to maintain tighter tolerance on that turn section.
Yeah. That's a cool idea.
It would totally negate that whole finger thing. Like it would just go in.
It would just fall in. And
yeah.
That's a cool idea. So next steps, adding that finger, probably, and actuating the spring. Like the spring insertion is currently manual. We had an interesting failure, which was forgetting to insert the spring, which is immediately apparent when you unload it, but it's just interesting thinking about like poka-yoke.
Mm-hmm.
Is there a way that we can make it obvious or impossible to move to the next step until you've achieved the previous step?
Yeah.
Or do we arrange the controls such that you're sort of actuating them from left to right?
Mm-hmm.
I don't know. Some way of ensuring that failure, because then you unload it, then you're like, oh, didn't put in the spring because it's all floppy. So then you disassemble it, put it back in and redo it. So that's waste. I mean, at least you don't scrap apart, but.
Yeah. Interesting.
Yeah. So that's been a ton of fun. And by the way, 3D printers make really crappy things, and those crappy things are so awesome. I mean, it's just like, I used to think 3D printing was like back in college. I was like, the product is not good.
Yeah.
But it is so good. Yeah.
Wrap your head around that one.
Exactly.
It's ugly. It's not exactly what you wanted.
Mechanically, the material isn't amazing.
No.
But the time spent is so minimal.
Yeah.
And it works really well.
Mm-hmm.
And if you're clever about it, it works really, really well.
Yeah.
I think. Anyway.
Yeah, it's pretty cool. I'm just dabbling, but
same.
I have lots of ideas.
Yeah.
So we added a generic setup point and call sheet / checklist.
Okay.
Still figuring out. When I explained point and call to the employees,
mm-hmm.
I was basically like, we just have to agree not to judge each other for looking ridiculous.
Are you guys doing it out loud?
I think so far I'm the only one who's done it.
Okay.
So basically the issue we are having, which I think putting it in lean principles would be defects, was that I had written an SOP, and this kind of harkens back to last episode of actually following SOPs.
Yeah.
I'd written an SOP. It was separate from our setup sheets.
Mm-hmm.
And so it wasn't getting followed explicitly. And there's certain steps in that aren't necessarily intuitive, mostly to do with documentation of the setup for repeats. And so I was like, how should we had a discussion at morning meeting, like, how should we tackle this? And basically the prognosis or the decision was just like, let's just make a thing right at the mill that is, before you put the green thing on the mill, you go through this list.
Very cool.
It's very generic and may need to be modified at some point, but I think it does the trick. And
that's awesome.
It's very visible. It's right where you kind of like mentally make that transition from setup to let it rip and,
mm-hmm.
and run with it. So I think it's going to be a big benefit. And so basically it was very generic. So it was just like, have you set your origins? Have you double checked your tool list and made sure that everything that's on the list is in the machine?
Yep.
Is everything aligned correctly? Was the first part within spec? Or are the parts running in spec? Have you taken photographs of the setup and loaded them back into the setup? And have you added any notes that needed to be added about the setup that were missed
mm-hmm.
in the initial? And have you confirmed that the G code you're running is uploaded back into the setup sheet? All pretty basic stuff, but I don't know, it's easy to forget one or two
right
every time when you're just trying to do it from memory. And I think eventually, as I've said, with our new setup sheet system, I think more of this is going to be built in as kind of a checklist as part of the setup. But I think this will still be useful as a on the front of the machine reminder.
Did you do this?
Yeah.
Every step. Yeah.
Exactly.
That's very cool. And so
they're mostly process defects. Like defects being that we don't have a fully documented setup sheet.
Right. So actually that's interesting. That's going back to moving away from thinking about the product being the piece of
Yeah.
material you're shipping to the customer, and instead the product is a total job,
Yeah.
completed, documented. Like sort of, it's more about the paperwork than the parts in a funny way.
It is. There's parts of it that are about the parts, like making sure they're within spec.
And that is what the customer is paying you for.
Yeah. But the majority of it is about our internal process. Yeah.
Yeah. Or maybe it is about the parts. I mean, it definitely is about the parts. It's just that is where all of the focus has been for years. And so that is not the struggle at all.
Yeah.
Right.
I think so.
Like, it's sort of a given.
What's a given? That the parts are going to come off the machine, more or less?
That you're shipping parts to the customer.
Oh, yeah. Right.
But all of the improvements primarily are around how that happens, how that comes to happen.
Exactly. Yeah.
Cool.
I'm excited.
In building that pneumatic assembly jig, we've been the last week we were walking across the shop to get the air hose from the blasting cabinet.
Fantastic.
Dragging it across the shop to the assembly area, doing our assembly, then realizing, we need to do more sandblasting, so we drag it back over there. Like that. Which, in looking at that, it's like egregious waste. I think there's a lot of examples of that where it's just a little less apparent, but it's as inane, like just silly.
Yeah.
In every sort of factory. I think a lot about that. Like, we are building these very small companies and refining stuff that, like, in very small spaces.
Mm-hmm.
I've been touring some companies, and all of these wastes exist, but are just massively bigger. It's like when you talk about putting something down and then picking it back up.
Yeah.
In a big factory, that's often like a 5-minute walk.
Yeah.
Like, no joke, right? It's like, geez. Yeah. So it's funny. It like hides a lot of the stuff.
Yeah.
The fact that we're in such small spaces, but it's still
right.
Bad. Like, us walking from one department to the other, sandblasting to assembly, is the same distance, probably shorter than a lot of people's one area.
Yeah.
Right. Like,
it's shorter than most people, like, getting from their dining room table to their sink.
Yeah. And so, like, it's still a pain, but I feel like there's a lot of places where you walk across to get an air hose, right, to blow off a part. And it's like you don't have one at every station. You have one communal one. So that was one of the observations. I think it wasn't Teiichi Ono. It was, I forget which Toyota. It was the son of the founder. Forgetting his name. Anyway, he went to the loom makers in England. Mm-hmm. And they were doing everything they'd make standard parts, but everything was hand fitted. Mm-hmm. And all of the vices and tools were on the perimeter, and the assembly happened in the middle. So you'd go try your part, and then you'd walk back over to a vise, pick up your file, walk back to the part. And so there's a lot of back and forth. Anyway, so moved the air dryer. So the air dryer used to be under one of the tables, but in our shop, that space is pretty prime real estate, and you never have to interact with it. So I moved it up onto a shelf high up, and then put another outlet at the thing. An air outlet at the assembly area. So that eliminates wasted motion in a number of ways. One, getting the air, but now we've opened up some nice real estate for keeping some more things. We're starting to run into limits on our space. So yeah,
that's real. Well, we bought a forklift.
Bam, that's exciting.
It was cool. Was not planning to, actually.
Okay.
Timing was not fantastic from a cash flow standpoint.
Yeah.
But I had been I had a Craigslist alert for the last year. I feel like I had a pretty good idea of what prices were.
Oh, cool.
This one happened to be only about 40 minutes away, maybe even half an hour away, and the price was very right.
Nice.
It's old. It certainly does not look beautiful, but it ran well. So that's kind of all I care about.
Yep.
And yeah, it's basically going to just make our whole life of unloading and reloading materials mostly a lot less dangerous. But also just less uncomfortable and probably quicker as well.
Yeah, safety's big.
Safety's big. Yeah. that's not, I guess, on there as a lean.
I feel like it's not a waste. It's
just like an overarching principle.
Yeah.
So yeah, mostly about safety. And actually it came in right and handy. We shipped out a 2,000-pound crate of product.
Jeez.
Like a few days after we got it. So it was really nice to be able to just pick it up and put it in the truck and not have to do a whole, we have a pallet stacker.
Right.
But it only works in this, on concrete. Our driveway's gravel.
Yeah.
It's like a whole to-do to try and get stuff into a truck. So it's actually probably where it's going to be the most beneficial is for our chip runs. I think it's going to probably cut like 45 minutes off that whole process.
Okay.
Just with getting the chip bins into the truck. Right now, that's a real thing. And I think this is going to make it like a 5-minute thing.
Interesting. I was going to check for an ROI. Just out of curiosity, 3,500 divided by 0.75 of a minute of an hour.
Yeah, but we only do it like once or twice a month.
Right. So, we'll do it offline. It's just interesting. I'm sure it's pretty long, but I feel like the safety thing is huge, and I've spent more money on less dangerous.
Yeah.
Yeah.
It's like the chip thing once or twice a month, sometimes more than that, but once or twice a month is an average, and then material every week.
I bet the ROI is not crazy long.
I don't think it's bad, and I think we'll end up using it for other stuff.
Right.
As my mentor said, it's the best pair of sawhorses you'll ever buy.
That's very funny. Fully adjustable.
Fully adjustable, and they'll hold as much weight as you want.
That's cool.
Yeah.
Nice. Let's see.
Oh, you tested the multi-tooth threadmill.
So I got a multi-tooth in there. I ran it. It was nerve-wracking.
Did it throw apart?
It did not throw apart. It worked great.
Cool.
I haven't yet implemented into production. I want to run some parts, do like full testing, make sure the teeth are formed.
Yeah, properly
and everything else. Look at them closely.
Were you able to get the right pitch?
Yeah, within like a couple thou.
Oh, cool.
And it's I mean, it is a functional face, but it's it needs to develop enough pressure to push into webbing.
Yeah.
So not super critical. In that way, the distance from the pivot pin is critical. So I just want to make sure it's not touching the ends at all. So I have to look at it under a microscope. This was again just Friday right before leaving.
That's exciting.
Yeah, very exciting. That could really improve our throughput on that. And again, it was kind of interesting. The things, so the things I was sort of thinking about, value add versus non-value add. In a mill, the value add is when material's being removed.
Yeah.
Right. So all of the linking moves. And if you look at time in the cut versus, it's often 50-50. So it depends on what you're doing.
The Brother machines have a display for that.
Ooh.
Yeah. It's not necessarily time in the cut.
Right. It's time in
it's G0 versus G1, G2, G3.
Yeah.
And M codes and stuff. But my experience has been most of our parts run in the 65 to 70% with the rapids turned down and 75 to 85% with the rapids up.
Interesting.
Yeah.
Yeah, that seems pretty good.
It's not like it's not like an indicator to chase.
Right.
But it can be, if you're looking at it, it can be a quick thing to be like, okay, this part has a lot to be gained, from a programming side, if we were to reduce linking, change our strategy so there's not so many linking moves.
Yeah.
Versus, this part has a lot to be gained by increasing our cutting speeds or something like that.
Yeah, sort of just where to focus.
Yeah. So there's a principle that it's your cutting speeds is the last place to try and cut time out of a cycle, because it's the highest consequences and also often the most difficult.
And so where do you look instead?
Linking is the first place. The Brother machines kind of take care of a lot of that for you.
With sheer speed or because?
Yeah.
Okay.
Because of their speeds, accelerations and stuff. Trying to remember what is an article I read quite a while ago.
Seems interesting.
Stuff outside the machine, obviously. And
Right.
yeah. Changing the type of cycles that you use.
Making sure it doesn't sit idle for 2 hours once the part that you ran really, really fast.
Yeah, I don't think that was included in that article, but it was kind of like, if you need to cut cycle time, don't immediately just like go increase all of your feeds by 50%.
Yeah.
Like there's probably lower hanging fruit with lower consequences.
Yeah, I mean, I was watching. So I've been. The other thing was I was sort of wondering about like applying the 8 lean wastes to machines seem reasonable, right? So like wasted motion.
Yeah, it took me a long time to realize, like looking at the Brother advertising material, that like it's named in like their motto is cutting out the waste.
Hilarious.
And I was like, oh, they're on board.
Yeah. Yeah. Speaking of which, this probably is more of a concepts question, but it's kind of a sort of. So if I am bumping up against cycle time, there is no doubt that increasing my batch size would decrease my per part cycle time, because I would eliminate tool changes, right?
How's that?
If I did a tool change and then used that tool over 4 parts, 8 parts.
Oh, if you went to multi-part flow?
Yeah. Mm-hmm. It's a disturbing thought. No. No, but I was sort of trying to figure out, like, how do I fit that in?
My world has been rocked.
Right? Like, to the lean concept of single piece flow, if I am already doing batches, like with these overnight runs, obviously the best option would be that each one of those vices holds a different part, so that I have single assembly flow, so that I have a balanced part list coming off of the machine. Which would be better, because they do use common tools across the different parts. So maybe that's the answer. But then if you get into massive, I don't know. I'm curious how Toyota thinks about that. If you get into like huge numbers of parts, like, are their injection molds all single cavity molds? I kind of doubt it.
Probably not. Yeah.
So like that is sort of the equivalent of what I'm talking about, right? You have like transit time of the mold opening and closing. You have injection time. You may as well make a bunch of parts with each cycle of the machine.
Assuming that the other downside costs don't outweigh it, which is like tooling cost, potential scrap cost.
Yeah.
All the other things involved with multi-part flow.
Yeah. So I was just kind of like, in no way am like, maybe we should go back to fixtures or what's it called?
Tombstones
pallets.
Or
pallets. Like there's no way that is more efficient. Like part loading is definitely the way for us. But adding vices is not a huge cost. Like if I put a trunnion on my machine and added a few vices, I don't know. It's very tempting. I think I'd decrease my cycle time pretty substantially. I have a lot of tool changes.
Gotcha.
Maybe the first thing is to eliminate tool changes, but I don't think I can.
Like you use 20 tools in a thing, so you potentially have like 30 seconds of tool change time per cycle?
Right. Probably not quite that much, but yeah.
Well, it's probably about 1.5 seconds per.
I don't think I have every tool in each part.
Gotcha.
Because I have like 2 parts are for the titanium pin, like 2 tools are for that. Yeah.
Okay.
Anyway.
Gotcha.
But yeah,
let's
close.
say 20 seconds.
Whatever. Yeah. 20 seconds out of 180 seconds. Currently.
So if you multiplied that by 4, you cut it down to 5 seconds.
Yeah. Anyway, it's there. So I was just kind of like, how do you balance single piece flow with the, like, okay, to be clear, the only reason we want to batch is because of the setup time of each tool. If it was instantaneous changes, there would be zero benefit.
Yeah.
Right. So like it is worth noting that Brother with their new machines, the X2 machines, shave it from, well, it's like,
I don't know, 1.3 to 1.2 or something.
Yeah. So like they're aware of that waste, but
yeah. Have you Are your tools sequential?
They are not yet sequential. I was looking at that. It's on my list now because I already need to redo my standardized tooling if I'm going to implement this multi-tooth mill. And so I think as part of that, I'm going to reorder everything so that the tools by proximity.
Yeah.
Just for listeners, like in the tool changer, if you're going from tool one to tool two in your part, you want those tools to be right next to each other in the tool changer.
Yeah.
So that the tool changer doesn't have to travel far. So getting back to wasted motion, I guess.
Their quoted times are for adjacent tool pockets.
Yeah.
You add some amount.
It's noticeable.
Yeah.
I watch a tool change where they're right next to each other and then one that's all the way around. And then the other thing while I'm at it is I've had a few probe tips get broken because my rougher is right next to my probe and it throws apart, and somehow if it ricochets just right, I haven't ever been there to see it, but I come back and my $180 tip.
$180?
How much are they? The probe tips. They're not cheap. $90?
Maybe they are like that.
I think they're around that. It's not fun.
No, it's not ideal.
No. Anyway, so I think I want to tackle that.
Yeah. Interesting. We started finally on a new trunnion design for our machines. I've been wanting to do this since September. Kind of came back from my MTS with this new plan for how we're going to implement a gripper for more automation. Bought some stuff and then got very busy.
Yeah.
I was also kind of on the fence about how we were going to tackle certain aspects of it, so I was holding off a little bit.
And so for anyone who's not like huge on fourth axis machining, a trunnion is basically so there's a fourth axis which turns parts on the table so you can reach many sides.
Yep.
And then a trunnion, the reason for a trunnion to exist is that you want to put more things on a fourth axis without losing rigidity-ish.
Yeah. So it's a table, basically.
It's a table that can tilt.
Yeah, tilt table. So I've been going back and forth on kind of like what our design criteria were. And I think finally came up with something like in the last month. And then this last week had an opportunity to schedule some time on the machines to do it and just decided to go for it.
Very cool.
And so the design was sort of half done.
Yeah.
But I had worked out the principles in my head. So actually, really what I did this last week was mostly design. Spent pretty much a day doing design, did start cutting. But I think it's going to solve a lot of issues relating to setups and SMED and cam templating. It's going to be like a whole new rollout.
Very cool.
Which I'm excited about. It's going to require buying some more vices too. But
so what were the problems that you noticed?
Yeah, so we have one machine with a full width trunnion where you can put 2 vices on it.
Okay.
And then our other 2 machines have rotaries with no trunnions that you can attach like a single vice to. And we're ending up with more and more parts that require 2 fourth axis operations.
Gotcha.
Which either means you have to design your jaws to carry op 1 and op 2, or you have to do a vice swap between op 1 and op 2. So anyway, it's just not ideal. So I wanted to design new trunnions that would have 2 vices. I wanted them to be able to use the pneumatic vices as well as manual vices that use a 96 millimeter 0-point pattern. And I wanted them to have minimal swing. So that meaning like distance from the outermost part to the center of rotation of the rotary. The dual station trunnion that we have on the one machine right now has a lot of stack up because it's got a 0-point plate on top of it. Then it has the thickness of the table. Then we added an 1.5 inch thick steel stiffener to the bottom. Okay. So you can't really like put anything in front or in back of it on the table without it getting hit. And the other goal I had was lowered overall width, so there was less interference with the spindle casting. Yeah. So I think I, in this design, have achieved all those things. Yeah. With a few compromises. Okay. But what it's going to allow us to do is mount a tray along the front of the table where we can pick up parts with a gripper.
Okay.
It's short enough in X that we should be able to put a flip station on the end.
Very cool.
And then we're making one that's slightly shorter that will go in the R450.
Uh-huh.
So if we want to automate that, we'll put the flip station and tray on the other pallet.
Oh, cool. Man, that'd be a slick setup.
That'd be pretty cool if, yeah. And then the last thing is to minimize the stack up issue. I sent you a link, but I found those precision ground sleeves. Yeah. So instead of doing a super quick change, it's a little bit of a compromise, but instead of a quick change, 96 millimeter, it will involve like just putting these sleeves in, dropping the vise over the sleeves without any pins in there, and then bolting it from below.
This just popped into my head. Probably not cost effective at all. Would it be worth pinging Lang or Fifth Axis to see if they would make you make that 0 point setup for you? Or do you think it would just be crazy expensive?
No, I don't think it'd be too bad. Like with the one single station trunnion I have, I bought all the hardware from Fifth Axis and milled it in place. Okay. But the issue is because I'm also trying to do the pneumatic vices. Yeah. Their bolt pattern is different, and then I'm trying to plumb the air through. Okay. And there'd be
gotcha. Too much going on.
Too much going on in
Fair
one
enough.
spot.
Yeah.
Yeah. And I suspect that the eventual thrust of this is not changing vices.
Right.
So
I have had the desire to change to turn my vise 90 degrees, even if I'm not. But I guess, yeah.
This will do that.
Right. It's just not quick, but that's fine.
Yeah, I mean,
it's going to be such a big improvement over.
I mean, we went through calculating 4 bolts. If we were doing it multiple times a day, I would
100% worth
making that effort. I suspect we'll be changing these around once a week at most, hopefully. Yeah. And maybe eventually never. Right. If we kind of design the workflow properly. Yeah.
And price that into your quoting.
Yeah, we'll see. So the kind of what we're trying to achieve here is wasted over processing and waiting, basically reducing setup times, reducing programming time, and confusion. So
probably defects.
It's all the things.
It's all the things, yeah.
But it's basically a big thrust towards SMED.
Interesting.
Having more or less a universal setup.
Yeah, that's very cool. Well, that's exciting to see.
And then I guess part of that is that our new post is almost done, which will allow us to probe the stock itself for rotary work instead of having to work from the center line of rotation. So
that's awesome.
In theory, we'll have a standard setup for all parts where it's every op one, you probe the top of the stock and you probe the sides of the stock. And regardless of whether it's a 3-axis or a 4th-axis operation. And that will be cool.
That's huge.
I know a lot of machines already do that, but it's been a challenge to get the brothers to do this.
Cranking on that for a while.
Very slowly.
I know they sell the chipset, but it's sort of now the machine can do it, but I still can't tell the machine what to do.
Yeah.
Very cool. I turned on tool life monitoring. I just basically initialized it to start gathering data. So you can record it in a few different, there's a few options. You can record how many operations it's used for, that tool, or how many minutes, or a third one that I'm forgetting. I went for minutes, and again, we literally just initialized them for, I forget, 20,000 minutes, which is obviously way too much. And then we're just going to see.
And it's a running counter? So you can
just counts down.
Oh, counts down.
Counts down. Yeah. So you tell it how much life, what your final life is. You can add a warning, a tool life warning at some other number, and you can tell it its initial life. And so, yeah, it's very easy. So if you have tools that are pretty standard, I would just turn it on. I wish I had done this when the machine was, you literally don't need to use it. It will just the next
Just
time you
logs.
go do a tool change, you can look and go, oh, that was this many minutes in the cut. Interesting.
Yeah.
Okay.
Write it somewhere.
I'll write that down and keep going and ignore it for now. But then at some point you go, oh, it's pretty consistently around this. Let's go, 5% below that or 10% below that for a tool change.
Yeah.
All of this is in the effort of going to overnight runs. I want to be pretty confident that we're making good parts.
Mm-hmm.
A lot of these carbide tools are like $12 to $50. And so relative to the value of even just the material we're going to run overnight, that's nothing. Mm-hmm. So if we can improve our chances of getting good parts out, that's going to be big. Again, I have no idea what our life should be set to. And so we just turned it on. So
cool.
Pretty simple. I think in terms of, I don't know what, I guess that's largely trying to reduce defects. Probably wasted motion because right now we sort of need to be on top of it, right? So we're always sort of checking faces, checking surface finishes, which I don't think will go away and probably shouldn't go away. Mm-hmm. But I think it will be less speculative in a funny way.
Yeah. Cool. We had talked about this a few weeks ago. We set up finally a standing UPS pickup. To stop driving to the UPS drop.
Nice. What do they charge you?
There's two different ways you can do it. One is like $10 a month.
Okay.
And it's basically if they're in the area, they will come by and see if you have something. You're not guaranteed to pick up every day.
Gotcha.
However, I'm pretty sure they're in our area every day. Uh-huh. They often come to our shop almost every day to drop something off.
Right.
So that's what we went with. There's like a $30 option they come every day no matter what.
Gotcha.
We didn't quite think that was required.
Fair enough.
So mostly it kind of 80-20.
And that's $30 a month?
Yeah.
Yeah, a run to the store, a run to the drop-off you're getting damn close if you do that a few times a month.
Yeah. So we're kind of tackling this as an 80-20. Like if we absolutely need something to ship overnight, we'll still go drop it off. But this is going to take out the majority of runs to the drop-off. Okay.
That's making me think. I keep meaning to do that. We'd ship mostly USPS, but I feel like I can get them to pick up.
USPS?
Yeah.
You have a mailbox?
It wouldn't really fit in the mail.
No, but they come by.
They come by. Yeah.
I'm sure you can make it happen.
Yeah. I just need to do the stuff.
Yeah. Talk to the people, make the stuff happen.
Yeah. That's cool. So that is what? What is that lean waste?
Wasted motion.
Of going to the place when they're already coming to you? Probably.
Mm-hmm. Wasted human potential.
Yeah. Although their drivers also
I guess
human.
not wasted motion, it's transportation.
Yes. That's right. Well, yeah, it depends how you look at it.
It's both.
It's both of those. Yeah. Because I think this is the interesting thing. I think a lot of lean organizations end up talking a lot to their customer, to their suppliers, to their business partners. Mm-hmm. Because it turns out that you are being if a UPS parcel arrives on your doorstep, you are already paying for that to happen. Mm-hmm. And so the fact that the UPS driver is now leaving without taking your stuff with them. Yeah. Right. And so if you can start to coordinate, I forget what book this was in. They were talking about trying to identify the real problem and solve that. And so if you ask a vendor to send, instead of doing daily deliveries, to do twice a day or 3 times a day, deliveries to your line, they're going to say, well, it's a lot of waste because the trucks aren't full. Right. And so some of these people organize a truck that goes between all the vendors to pick up a third of a truck of stuff and then drive to the factory. And it's that takes a lot of cooperation. But anyway, that's interesting. Yes. I also ordered, I ordered a bunch of stuff to try to improve cycle times. One of the other things was we had talked about taller hardened inserts for Op1 gripping of the stock. So those are in. I haven't tried them yet. But I was basically thinking that the added, it's funny because it turns out that I already have room for this, but basically if I can grab onto more material, I can probably rough harder substantially, which will reduce cycle time. The real thing I'm running into is sometimes if there's a burr, it's very intolerant of a burr because the burr represents a meaningful percentage of the amount of material it's gripping.
Yeah.
And so this will reduce our chances of breaking our roughing mill. And then the other thing is actually by holding on to more, I'm wondering if I can actually reduce the amount of material we use, because on our cams, we have thick stock for rigidity, not for... So I could go to thinner stock. I was almost thinking about milling a pocket into the vise that the stock sort of sits down into. So it would be like cantilevered out and then just go, I don't know. It might be a bad idea. Do you know what I mean?
Yeah.
Because I'm like cantilevered out. And so I'm trying to deal with these like bending forces.
Yeah.
But I think if I pocketed it into the vise.
I mean, the thickness of the cantilever is still going to be a limiting factor.
Yes. But right now I'm doing it because I need a wider base to grab onto.
Yeah.
Anyway, it's just a thought that in a sort of paradoxical sense, by grabbing more, I might waste less material.
Yeah.
It's sort of funny.
Worth trying.
Yeah.
Cool.
Yeah, I think that's kind of it.
Yeah.
And thanks all for listening. You can find me on Instagram at austere_manufacturing.
You can find me on Instagram at Lycan_MFG.
And the podcast at Incremental CI. Yeah, love to hear your feedback. All thoughts are welcome. Some folks have started emailing us some really in-depth info, which is super awesome. I feel bad because I haven't done the best job of responding with equal in-depth fervorness. But it's super appreciated, and I've read through it now twice. I feel like the one guy emailed us about data entry and data storage and naming conventions that were really clever and simple and easy to manage and prevent duplicates, which is very cool. Anyway, so thanks all. Until next week.
See ya.